Hello, my name is Thornton, and today I'm talking about our paper, 50 Shades of Grey, in praise of a nuanced approach towards trustworthy design. This paper represents the first stages of our thinking in this area and is therefore part of our ongoing work. It stems from our considerations of designing technology that is trustworthy by design, specifically using design as a process through reflection on our conversations, observations, and our own experiences, with a focus on virtual labs for environmental data science. When reflecting, we thought about the nature of trust and how certain features of systems and technologies are often conceived of as simply importing widgets into any context and are often presented as automatically leading to trust. For instance, that transparency automatically leads to trust, or similarly, that provenance does. We don't argue that transparency or provenance are not worthy ideals, but we instead argue that these concepts do not carry a singular interpretation and can carry many different understandings to different stakeholders. Whether they promote trust is actually a function of how designers consider various potentially conflicting stakeholder trust needs and how these are perceived by the end user. Our work explores how each affordance contributes to trust for whom and what this would need to look like in order to promote trust for a particular stakeholder in a specific context. We believe that the use of trust affordances can potentially be useful to help designers consider many different stakeholders when thinking about what a technology affords. We came to find that trust affordances would need to vary in their final form even within the same system, and that even when we start from a position where we know that trust is important to us, defining design requirements is still challenging. What we advocate for then, following on from using trust affordances, is greater consideration of these concepts, for what we call a nuanced approach, considering many shades of grey. There is already a wide body of literature on trust with many different interpretations, definitions, and theoretical orientations. The key points that we want to highlight are that there is no one-size-fits-all approach or singular solution to trust, that trust is context-specific and person-dependent, and that trust is multifaceted with many different types, levels, and objects in which to place trust. We want people to place trust when it is appropriate, i.e., when it is trustworthy, and withhold placing trust when it is not justified. Therefore, it is about providing evidence of trustworthiness that can help users themselves to determine whether they should or should not place trust. We believe that it is important to state these at the outset, as how they are interpreted by a designer affects how they ultimately design for it. We take a trustworthy by design approach, which means putting thought into trust early on in the process, as trust is difficult to retrofit into a system once it is built. But when it is a clear aim from the outset, we can sufficiently account for it and hence design for it. The area that we work within is environmental data science, which involves the application of data science to the study of environmental processes. There are many complexities and interdependencies within environmental data science. For instance, there are many complex feedback loops and interactions, but whilst all these systems are interconnected in nature, this is often not reflected in practice, and treating processes in isolation can impact upon the completeness of our knowledge about the environment and the effects of one system upon another. The isolated nature of the study of these systems is connected to the structure of scientific practice, as there are many different disciplines and sub-disciplines, each of which has its own norms, methods, and ways of doing science. However, in order to answer increasingly complex environmental questions, we require some means to overcome these silos. Environmental data science is inherently multi- and transdisciplinary, including not just all of the different environmental subdisciplines, but also social, economic, political, medical domains. There is therefore a need for infrastructure that can help to tackle these challenges, facilitating collaboration in order to answer these questions. In combination, this means there are a multiplicity of trusts to consider, as there are different stakeholders, from environmental scientists to those working outside of the domain, such as statisticians, computer scientists, and social scientists, and even those from outside of academia, for instance, communities of practice, legislators, and members of the general public. Each of these stakeholders places or withholds trust in different things and in different ways, For instance, placing trust in data and models, in scientific results, in policy, and in other people in order to collaborate. Our reflections are based upon ongoing work in developing virtual labs, as these provide a space and a place for multiple stakeholders to find information, conduct research, and to communicate. Virtual labs are fairly conceptual and abstract, meaning that they are not strictly defined. And our work has been focusing on developing this concept and instantiating this into practice. This gives us the opportunity to take the time to consider a trustworthy by design approach and led us to both consider the challenges and the opportunities of this technology and develop the trust affordances approach to put these into practice. Essentially, virtual labs are online research environments capable of providing access to data sets, analysis and visualizations for a range of stakeholders. They can be thought of as transdisciplinary collaboration spaces that are hosted by the cloud and are accessible through web browsers. They combine features of data repositories, such as providing access to data and related metadata, but they also enhance this by providing tools and services such as narrative, visualizations, and communication. Virtual labs therefore provide a socio-technical system to address socio-technical issues. However, even when we know that trust matters, designing for trust is still challenging, and this led us to consider how we could attempt to formalize the process. We found that using affordances can help us in this endeavor, particularly given the complexities of trust and the complexities of environmental data science. And we utilize the theory of affordances, in particular looking at conceptions that take into account people and context. Affordances were originally developed by Gibson and then translated into HCI and computing by Nordman and Gaver. And these approaches are useful, however, they are limited. For instance, the former focuses on utility and is limited in its application to technology, and the latter focuses on use and usability, which leads to an overemphasis on user interfaces. Recent conceptions of affordances led us to an understanding that what a given technology or system affords users and how that technology or system is used differ within different social and cultural contexts and also over time. Affordances may also be two or multi-sided, meaning that the same design attribute can be different for multiple users. These approaches also show that affordances can be impacted by learning, change, and practice. Therefore, the relationship between the user, the context, and the artifact thus affords a particular action or activity, and individual users can employ a specific technology for different goals and have agency in how they use it. We define trust affordances as characteristics of the technology by virtue of itself or of features designed into the technology to promote trust by providing access to evidence of trustworthiness or distrustworthiness specific to a user, a technology, and their context. Thus, whether trust is promoted relies on consideration of multiple stakeholders and their particular context. Trust and trustworthiness, as discussed, are both context dependent and based upon what each individual needs. We therefore mirrored this with our definition of trust affordances. They are specific to a user, a technology, and their context, and may or may not be interpreted as such by the user. We began our application of these trust affordances by looking at concepts of transparency and provenance, which we noticed were mentioned fairly regularly with regards to trust and systems. Transparency and provenance are not affordances in themselves, but have different affordances which may or may not feed into them. So firstly, we looked at transparency. Transparency and trust are frequently connected. For instance, if a system is transparent, then it will be trusted. However, in reality, it is not as clear-cut as this, nor as simple. During our reflective process, we began to unpack what transparency actually meant, and that it could be interpreted in different ways. For instance, taken one way, it can mean that all information held within a system or all backstage operations behind a system may be visible, but this is perhaps not realistic and rarely happens in practice. With regards to information and transparency, complete openness may mean that a user may be bombarded with a massive information that is not intelligible or with too much technical information that is not relevant to them. It simply means that it may not provide whatever evidence is needed to place trust, even if all information is placed there transparently. It all depends on different stakeholders and their need for trust. For most people, however, it can be time-consuming and hard to navigate evidence in order to appropriately place or withhold trust. This approach would rely on users having sufficient skill, time, and ability to interrogate information and to have the capacity to make rational judgments based on this. This is frequently not the case, even for experts. We then began to reflect upon translucency too and realised perhaps that this is more representative of what is meant, i.e. that all relevant information is available to a user rather than that all information is available to a user, especially given that what is evidence of trustworthiness differs between different stakeholders. So while transparency is a worthy ideal, we realise that it requires thought when it comes to affordances. We argue that we cannot simply state that transparency contributes to appropriate trust without delving further into what this means in practice. Within the paper, we mentioned 3 trust affordances related to transparency. These were scrutability, abstractability, and reciprocality. Scrutability referred to the ability to scrutinise a system and its components. It was concerned with the amount of the system and its features that are shown to users, including the amount of information that is presented. We found that what types of information are visible and further how users can search for or request additional information are relevant to transparency. For instance, an ability to engage skeptically with a system, obtain additional information, and to scrutinise various elements when determining trustworthiness. We also found that there was some crossover between this and the trust affordance of abstractability, which referred to the ability of users to access the same project, but dependent on their ability, so that if they didn't have as much ability, they could still access it. And also reciprocality, which again is similar in that it refers to the need for documentation to be tailored to the individual needs of recipients. Being able to ask questions and receive reliable answers help to promote trust and align trusters and trustees' expectations. So, depending on your definition of transparency, which may relate to inclusion of all information publicly, in reality, this is unrealistic, especially within our application. For instance, scientists are used to only publishing the end result and not the entire scientific process. Moreover, any information presented may not necessarily lead to understanding and trust for users. We would need to provide different types of information at different levels of abstraction. Virtual labs can provide this as they enable workspaces with different programming languages, but on top of this, they also enable shareable and editable Jupyter notebooks based on this data, and at a further level of abstraction, it also enables graphical user interfaces such as R Shiny. Therefore, users can access the same information based on their own needs, and additionally, users can interact with others by asking questions to gain additional evidence. Within the paper, we noted, however, that these affordances raise certain questions. For instance, what questions do people need answers to, and what evidence would serve to answer these questions? Which formats of abstraction are suited to whom? How do we know that this has led people to the information that they need to form well-placed trust? And whilst we can generalise and provide the information that we might think might be meaningful, without a mechanism to address any question, it is more of a unidirectional flow of information. But on the other hand, do these approaches place a greater emphasis and strain onto scientists who must now take the additional time to answer these questions? We then moved on to consider provenance, which relates to the origin and history of an object. We noted that there were different types of provenance, e.g. coarse-grained provenance, which captures relationships but not complete insight, and fine-grained provenance, which provides a comprehensive account of all information pertaining to a dataset or model. The varying granularity of provenance connotes different affordances. Within the paper, we proposed 3 provenance-related trust affordances. These were verifiability, persistence, and traceability. With regards to our work, evidence of trustworthiness may include integrity, authenticity, and reliability, and this can be viewed in a purely technical way, such as recording where data has come from and providing assurance that it has not been tampered with. Here, the trust affordances of traceability and persistence are relevant, as trust may be afforded with this record and assurance, and also that it's not been changed from what it originally was. Additionally, in highlighting the interconnectedness of different trusts, these issues also relate to trust in other people, for instance, through identity. Knowing whom created and preserved the data enables an individual to make trust assumptions. The affordance of verifiability thus relates to both that the data is what it was originally recorded as, but also it relates to the person or persons who collected this data. This illustrates the multi-sidedness of affordances. However, we also know that it could be potentially problematic for some users. Preserving identity is key to being able to verify and determine trust, but for others, it inhibits collaboration and reduces trust. There is also the issue that identity does not provide a basis for trust for those who are not acquainted with the domain, and therefore, in other cases, evidence of trustworthiness will be required. Related to the affordances of traceability, we also noted that scientists can often be reluctant to share data because of a fear that this will be taken and used erroneously. Trust may be afforded for scientists with evidence of the forward provenance or propagation of their data, but on the other hand, this may be an unwanted affordance for commercial users of virtual labs who do not want to promote or share which data they've used within their analysis, and they want to protect their intellectual property. As with transparency, provenance also raised several questions. For instance, what specific types of provenance are required for different stakeholders? Can these be generalized to a group level? What specific features of a virtual lab will be needed to cater to these needs? And how can we balance issues of identity based upon an individual's preferences? Within the paper, we also included this mind map. We believe that it illustrates the complexity of designing for trust and trustworthiness. As you can see, transparency and provenance were the starting point, and we can see how these branch out into lots of different affordances. Although we must be explicit that this is by no means an exhaustive list of affordances, and nor is necessarily applicable to any other context, but it provides a starting off point which we can base future work. So, reflecting on our paper and our progress, what started off on the surface a relatively simple problem, which was designing a virtual research environment for environmental data science, soon became increasingly complex. By being true to the nature of trust and environmental data science, we want to respect that complexity, and we do not feel that majorly simplifying everything will ultimately be successful when this is put into practice. As we are at the beginning of the journey in designing for trust within environmental data science, we feel that there are many more avenues to uncover, and moreover, within the paper, we do pose many questions that we yet don't have the answers to. The design process is fraught with decisions to be made and competing interests to be balanced, which, as we have shown, are not necessarily as simple as they initially appear. Therefore, how can we capture all of these competing interests and map them in order to address them? It's one question. A nuanced approach also enables us to consider trust at a finer level of granularity. Design decisions have to be made, but we can't design a system for each individual user. However, as we scale up, we may lose some of the nuance, and therefore another question is, what is the right balance in this? Another question is, how do we gain by understanding this complexity? It stops us thinking that our job is done if we simply say that a system has provenance and transparency. But it forces us to think about multiple user needs, which we believe is really important. Ultimately, we've used affordances as a tool to navigate through all of this complexity and to design for trust in a thoughtful manner. Affordances can all contribute to trust, but we should not assume that they afford trust in all instances. This also raises further questions about how these would apply beyond our example case. In our future work, we hope to do more empirical data collection about different views of users and stakeholders, addressing questions of whether we can scale up or generalize these. We're thinking about putting those affordances into practice as specific features or properties, how these would actually look within virtual labs. In conclusion, Being aware of the multiple complexities present in trust and environmental data science and the need for consideration for multiple stakeholders, we have developed trust affordances to provide a basis for designing for trust from the outset of the design process. We have shown how using this concept has enabled us to take into account context, stakeholders, and different needs in their application to virtual labs. What we hope to convey is that a nuanced approach is appropriate when designing systems and technology, when considering trust, and we hope that this does not mean that any other approach is futile, but perhaps there is a middle ground, and this all depends on the specific context in question. Thank you for watching my presentation.